Hello, welcome to today's webinar. We are happy to have you with us for this California Energy Design Assistance session, Energy Modeling Done Right, Optimizing Building Energy Outcomes. I am Connie Umfris, Communication Manager at New Buildings Institute. A few quick housekeeping items before we start today. First, you are muted and we cannot hear you. This helps keep the background noise down so that everyone can better hear the speakers. I want to direct you to the dashboard that you should be able to see on the right-hand side of your screen. If you are having technical difficulties and cannot see the slides or hear our speakers, you can use the question pane in this dashboard to let us know, and we will help you as we go. We will take a few questions at the end of the presentation. Please ask questions in the same question pane. Please take a moment to answer the survey at the end of the webinar. We consider your input in the planning of future sessions. If you are seeking AIA credits, this survey is where you will share your AIA number for credit submission. And finally, this session is being recorded. All registrants will receive an email tomorrow with links to the recording and slides for the session. If you need a certificate of attendance for your records, it will also be part of tomorrow's follow-up. Here is today's panel. I will pass the mic over to my colleague, Alexi Miller, who will begin today's presentation.
Hi, everybody. Good morning or afternoon, depending on where you're at, probably morning for most of the California folks on today. I'm Alexi Miller. I'm the Associate Technical Director at New Buildings Institute, and happy to have you on today. We're going to talk about energy modeling, and in particular, energy modeling in the context of California's recently launched California Energy Design Assistance, CEDA program. So we've got a couple folks from Willdan who are helping implement that program, as well as some people with experience in projects that have tapped into energy modeling. On the owner's side, that would be Farah, and on the designer or modeler side, that would be Neil. So thanks for joining, and without further ado, let's dive right in and make sure. Okay, great. So things are working. So we'll go through that with introductions. I try to keep it pretty brief. Jeff Glover from Willdan is going to give us an introduction to the CEDA program, and then I'll talk a bit about some of the key stages of the design process and in terms of energy modeling in particular. We'll hear a couple case studies. That'll be Farah with an owner perspective and Neil with an expert designer perspective. And then Rich Pesky from Willdan is on as well to talk through some of the kind of technical details about what we mean by modeling in the CEDA program, how it works, and what you might be able to, how you can tap into that and what that means for you in a bit more technical sense. And then we've got some time for Q&A at the end. All right, without further ado, Jeff, you are off and running. Thanks for joining.
Thank you, Alexi. Appreciate everybody on the call today. So we're going to dive right into it. The California Energy Design Assistance, CEDA. Let's do a program introduction. And let's see.
You should have control now, Jeff.
Okay, that might be a little lag.
Yeah, I think, yep, you should be able to click through a little bit of lag. You're up, it's moving.
There we go. Okay. All right, let's start off. What is CEDA? California Energy Design Assistance. Basically, we provide a free analysis of varying different energy efficiency options, and we lay out their potential energy savings and provide incentives based on energy savings in new construction or major alteration projects. So it's not just ground up new builds. We can also enroll existing buildings that are considering gut rehabs or major alterations. So what kind of buildings can tap into the CEDA program? A wide range, publicly owned properties, municipalities, commercial entities, high-rise multifamily, that's 4-story and higher. We can enroll industrial projects with process loads. We can enroll agricultural projects. So a wide range of projects can tap into the CEDA program. What what investor-owned utilities are participating. That's PG&E, Southern California Edison, SoCal Gas, and of course San Diego Gas and Electric are eligible. One major takeaway from today is probably timing of the program. Since we've launched in August, unfortunately, we've had to turn away a few projects because of timing. If a project has moved into construction documents or later, unfortunately, it would more than likely not be eligible for the program. So I know Rich will dive into this a little later, more detail, but we can't stress enough, if you know about your project, the earlier the better. Get that enrolled into the program. We have to show a level of influence on the project in order to pay out those incentives. So the earlier, the better. So number one takeaway I would say from today is timing of your project. Again, never too early to get that project enrolled. Once it moves into CDs beyond, it unfortunately would not be eligible. The process, we've made this in conjunction with the utilities a very simple process. The enrollment, it's an online application. You fill out some particulars about your project. Takes maybe 5 to 10 minutes to submit an application. We'll review the data. We'll review the building characteristics, and once we have all that data, we'll get it approved for the program. Once approved, we're going to assign a project manager who will reach out and start step number 2. That's a preliminary analysis. And during this first meeting, which is roughly hour and a half long, we're going to do some real-time evaluation of different measures and what we call bundle selections. Basically, the potential for whole building strategies for further analysis. So we'll start that process of evaluating what measures we should consider. Then we'll move to the third step. Again, another hour and a half long meeting. During this process is where we're going to make final decisions, determine strategies that best align with your goals, projected energy savings, and of course the utility incentive will all be determined at this final analysis, and then this is what the project will in fact design to. After step 3, from an owner, an owner-developer standpoint, architect even, we pretty much go into construction, and then our team will come in after occupancy and do a verification just to confirm that what was planned was in fact installed into the project, and then we'll report that back to the utility, and then the incentive will be issued again for strategies that were implemented. So it's really a very simple process. So who's eligible for the program? Again, I touched on new construction, ground up build, or existing buildings that are considering a gut rehab or a major alterations. Again, reiterate, projects in design, be it pre-design, schematic, design development. Again, it's never too early to get your project enrolled. And of course, we're looking for projects that want to exceed the standard practice code and the current design, and of course, be willing to pay into the public purpose program surcharge on the account where those EE measures will be installed. So those are some of the eligibility factors. Also not shown here, we're really looking for projects 30,000 square feet and larger. So why participate in SEDA? Well, here's what you're going to receive when you enroll. You're going to receive that complimentary custom energy modeling from our team. You're going to get help identifying, evaluating energy saving opportunities. We're really trying to help pinpoint that sweet spot between your budget and maximum energy efficiency. That's really what we're trying to help identify by enrolling in this program. Again, analysis of energy costs and paybacks, and of course, again, the financial incentives to help offset the cost of implementing some of those energy saving measures. With that, Alexa, I'll pass it back to you.
Thank you. Appreciate it. All right, so I would like to give you a little overview of some of the key strategies that we at New Buildings Institute and our partners have found to be particularly important over the years. You know, we've been looking at zero net energy buildings or other high performance building types, as well as, you know, a wide variety of other buildings from all the way, you know, very high performance like zero net energy, all the way down to, you know, much more straightforward buildings, some that in fact don't do any energy modeling at all, and have found that there's a couple points in the design process that are sort of some leverage points. And we found actually energy modeling is a really powerful tool for improving building energy performance. And there are some basics on making sure that potential is realized. So a couple of the key benefits, one is getting a holistic representation of building energy use. So thinking about where energy goes in the building and what you get out of that building. And basically doing the energy modeling, especially if done early, like Jeff mentioned, never too early, right? There is, of course, too crazy early to do energy modeling. That is such a thing, like what is the building we're going to build? We have no idea, but pretty early in the game, you can start getting some ideas about what kind of systems you might put in. And you can start thinking about where the building goes on the site, massing, maybe HVAC type selections. It can help inform some pretty early stage decisions that then allow you to make more informed decisions about the more detailed pieces, the fine tuning farther down the road. And the point overall is to keep the energy costs, the operational energy usage in terms of cost, and the impacts in terms of things like greenhouse gases minimized over the life of the building. So when we talk about using energy modeling as a design tool, we've thought of there being a few kind of early stages in the project. A couple of things we've found to be really important at these particular stages. One, right at the beginning, is setting an energy target, and often that's something like an EUI, an energy use intensity, kBTU per square foot, in the documents like the owner's project requirements. That target then can help inform the energy modeling. And by the way, we have lots of good EUI targets available, zero energy and otherwise, for both new and existing buildings. So if you're wondering what that might be, we have resources on that. But then in the early design phase, you can use this complementary energy modeling, get that preliminary or shoebox type analysis, get an idea of some of those packages, and start making some early decisions on what might go into the building. Then there's an optimization step where we're thinking about optimizing the building energy consuming systems, the mechanical systems, as well as things like the envelope, windows, insulation, airtightness, air sealing, and trying to think about opportunities for trade-offs, say spend a little more on the envelope and not have to spend as much on the HVAC, because you don't need as large of a space conditioning system maybe if you have a better envelope. So there's optimization to be done in matters large and small there throughout. And then of course, you know, you build the building, confirm, and are eligible for the incentives coming down the road. There are several standards. ASHRAE 209 is a pretty good standard for energy modeling. It's quite detailed. If you're going through the CETA program and you're trying to use this complementary energy modeling, you may not need to know all the details of ASHRAE 209, but I wanted to throw it in here to show that you've got several steps in that standard, or several components of that talk about the use cases or the applications of modeling throughout. But there's a lot on there, and I'm not going to read that whole slide. I mentioned setting targets early in the project. So whether that is in energy usage as an EUI target, or whether that's an emissions target denominated in greenhouse gas, either way, it's quite important to set that target early. And we've found a lot of projects have been able to achieve high performance, zero net energy, or just generally significantly better performance, in part because they set a target early and they got buy-in from key team members and kind of stuck to that target. And then there's also the potential to think about system level targets for efficiency at the component level or at the end use level, like is shown having conducted those, then you can do this energy modeling, and doing it early in design. I kind of mentioned this at the beginning there, but you can think about things like orientation of the building, the massing, try to optimize that floor plan, and then think about things like adjacencies. So is there a corridor next to a use space, and are there energy flows between those two areas? Is there a key energy consideration related to how you're laying out the building? And then is there some impact from that on what stuff you're putting in the building, whether that's mechanical systems or stuff like envelope? And those, some of the answers to those questions can start to shake out from some of this, even some of this preliminary early modeling. Some of the strategies that we've found are important to think about are listed here. I'm not going to read all of them, but I want to note that these include what you might call passive and active strategies. Passive stuff like insulation or natural ventilation, active strategies like things with motors, right? HVAC, pumps, lights, controls. So those can be considered and compared baseline to proposed, as well as compared among each other in a holistic sense. That's part of the game of this holistic energy modeling idea, is to be able to think about the contribution that each of those components makes to the overall performance of the building and its energy use. And then we've got ongoing design. Let's think about those packages that were thrown out there, choose specific measures or final packages, and do that fine tuning. Often teams do iterative energy modeling to really get this stuff nailed down. And then of course it can help inform the handoff for the building operator. So we have some idea how all the pieces are supposed to run, and that helps make sure that the building actually can live up to its potential. We modeled a great building, now let's operate it and get a great building, operate it as it should be done. And finally, within the this program and in general, there's a final step of a verification, and of course on to the incentive. And I think we're skipping that today. So Connie, if you have it, Farah, our guest presenter today, Farah had a project emergency and she is on site putting out metaphorical fires. So she pre-recorded this little chat for us.
Hello, my name is Farah Fazaneh. I'm the Director of Facility Planning, Emergency Management, and Construction at San Bernardino Community College District. At San Bernardino Community College District, we have established a set of goals that include zero net energy buildings, LEED Gold or higher certification, as well as low EUI targets. We currently have a lot of construction activities happening in the district with upwards of 15 new construction or major renovation projects in the pipeline. We want to ensure that our buildings are planned and ready for the future. Energy modeling plays an important role in this effort. Remember the old saying, if you don't measure it, you can't manage it. Therefore, we don't want to see energy modeling used only as a check mark. We actually ensure that a lot of our decisions are driven by the information collected through the energy model simulations. It allows architects to virtually experiment and evaluate different scenarios to allow us to weigh in the benefits of different options. It allows us to take a measured risk by providing us information about the energy efficiency measures that is not yet widely adopted. To name a few of the recent examples, we have decided to implement solar chimney, solar glass, DC-DC distribution, and phase change material for our technical buildings. So remember, energy modeling allows us to push the envelope with little to no risk. So take advantage of this great tool. Thank you.
Great, thank you. Thanks, Farah in absentia. I believe she's going to be able to join for the Q&A, assuming that the fires are not raging metaphorically at her project site right now. Now we're going to hear from Neil, who is an expert modeler and runs Redcar Analytics. Neil?
Yeah. Can you hear me?
We got you.
I think, let's see if I can move our slides along here. So, hi everyone, my name is Neil Bolger. For those of you that don't know me, I've been in the realm of energy modeling and design consulting for a little over 12 years now. And today I'm going to just try and share briefly a few touch points on how we have worked doing building design enhancements with energy modeling, and where I can provide my experience and maybe some ideas that can inspire others as they're working with teams, or even if you are on the owner's side, how you might best work with an energy modeler and your whole design team. So in the theme of today's meeting, I really focused on thinking about the value an energy model can bring to a design in the perspective of what different teams might be focused on. You know, all teams might be focused on a low energy building. That is a goal we all share. And I think the success I've had is to think about clients and realize that while everyone may have, they want the best building under the sun, and everyone has the same general list of maybe 15 goals, some goals kind of float to the top based on who those clients are. If it's a public facility compared to if it's a private office that's built to suit a new headquarters, let's say, you know, they might have different goals for what they're looking to achieve. Maybe EUI is a number they all want to target, but the second one on that list might be different depending on who it is. You know, it could be operational carbon, perhaps might be the top of a list for a headquarters, whereas a private development on the right, you know, they still want to be a low carbon building, though they have other constraints. They're trying to make their first cost work, trying to downsize the cost where they can, really put the money in the best location, make something maybe that's modular. You know, they're trying to attract lots of different tenants. And I think being aware of those goals can really help an energy modeler be successful to sort of pull the right information out of an energy model for a team to make informed choices in ways that we know they're already having conversations together. So I was just going to share a few examples of this, and sort of before I dive into that, kind of speaking to the challenge of energy modeling. You know, from early design all the way to making the building, we're surrounded by lots and lots of ideas, and there's this struggle of how do we analyze all the ideas that are being thrown at us? Like, what is even the right approach? And I need to build an energy model, but which energy model? And does it need to be an energy model? Are they asking me questions that might be around daylight or comfort? And I might need a different model. So an idea I always preach is to really think about the deliverable, and even think about what is it we need to answer first, and really figure out, like, is there a meeting that's in 3 days and I need to help answer a question, or do we need to come up with something in 2 weeks? And letting that kind of flow all the way through, really setting the tone for, well, what is the model I'm building? How accurate does it need to be? How much information am I being asked to bring to the table? Do they want a 20-page explanation of what I'm doing? Do they want a 5 words about what the EUI is? And for us, that's really been our way to then say, great, well, for at this instance in the project's design, this is the analysis method we're going to use. Or, you know, maybe we decide on this instance, we're going to make a few simple models before we dive into the full building, because they haven't even figured out the mass yet. So, you know, taking that into consideration, there's lots of tools out here. People can use these tools. I've just thrown a few on the page. You know, some of these tools are more optimized for different stages of a design. You could use them in any stage, but you know, sometimes even switching between tools, as crazy as it can feel, if done the right way and really thinking with the design team's best motivations in mind, can be a way to actually be successful in helping clients really, at the end of the day, understand what's the relationship between how they're designing the building and what it's going to use in energy and feel, and being that sort of building translator. So some examples I'm just going to share. You know, this is my public building. This is a public education nature center. You know, it was a really beautiful little building that was going to be these indoor-outdoor classrooms, and for them, they really wanted to hit net zero energy, really make a building that was robust, easy to operate for the staff that were going to be there. So from day one, they wanted to set a goal for solar generation and how can we position that building to maximize output. And sort of working through them, you know, we really used EUI as the main target for that project. On the right side, we figured out the maximum PV they could even put on a roof, which we were then able to help turn into a number of solar panels and a cost that they could evaluate. And then we worked left to right, bringing that building's energy down as we weighed different options from the envelope to the systems that went in it. So kind of using, for that client, those goalposts of EUI and then energy potential on site. The other fun challenge there, it was in a climate that snows, so the solar output wasn't the most, and it also gets very cold. So a big piece that we even helped do, and this was actually with a shoebox tool that's online, was helping them figure out that, while we might want to buy really high performance windows to bring the energy down, it will also make the building more comfortable and less drafty when you have a classroom with students sitting next to the glass or pretty close to the glass. You can really have an impact. And this is an online tool that just demonstrates a range of what comfort could be as a distance away from the glass. And so we were able to just take a classroom and help demonstrate very quickly what is the potential of improving comfort as well as energy to try and hit a few goals in one foul swoop. My other example on like a core and shell office building, for this project, again, we have an EUI target we're really focused on, but here we dove into the fact that at the stage we were pulled in at, we really wanted to help express that improvements to the envelope could also mean improvements to usable space in the building. And while the building may have a certain aesthetic goal in mind, there's these glare risks and comfort risks where too much glass can actually inhibit how flexible part of the floor might be. And while that might end up being where we want to be in a building, we also just want to sort of go into things eyes wide open, right? If a client wanted to move into this building and put people all the way up against the west facade, how challenging is that going to be? And if we make that more comfortable, how can that sort of give them that other goal they might have, is flexibility in their building that they're creating. So kind of using both, right? Knowing an EUI target, knowing we have to get there, but then knowing people don't always just think in bar charts and need to be able to relate to the model in other ways. For this project too, we also focused on just bringing pictures and examples from other buildings so they could understand how other projects that did decide to do more glass, for instance, created a buffer space, created a corridor, which is a great way to go in a building if you have the flexibility to do that. So a lot of times we'll try and couple an energy modeling analysis, a visual chart, with real pictures of how that would look in reality as a way to better translate what it is we're talking about to clients. The last example on this core and shell building I'll throw in there is, I think, speaking to a value of an energy model can pull out a lot of great information. And early on, we realized that our model actually is one of the only things that's in the design team that can look at peak loads, air conditioning loads on a certain side of the building, and really working with the engineer to say, well, this is what the model says. We know you're going to make a final load calculation perhaps later in the phase, but for choices today, how can we turn that from, let's say, engineering numbers into things that the whole team can understand? So we quickly translated this reduction in glass into, well, how many fan coils could we delete out of the building? If we went from this much glass to this much glass, could we drop 15 tons on the west side? And what does that look like in terms of moving dollars around our design? So again, just trying to take the best value we can out of our simple models to really put it into numbers that people can digest and take action with. So lots of uses, but happy to be here. So
Thanks, Neil.
Yeah.
Pretty cool stuff. Making buildings better in terms of energy and outcomes for the people that sit in those buildings. And now we've got Rich to talk a bit about how CEDAR does modeling and what goes in, what comes out, and how that works potentially for your project.
All right, thanks, Alexi. And just a quick introduction for the folks that I haven't worked with before. My name is Rich Pesky. I am an energy project manager with Willdan. My background is in architecture. I practiced architecture in the Twin Cities in Minnesota for many years before jumping feet first into the energy field. So I've been with Willdan doing energy work for about 7 years now. But I just wanted to take a few minutes here, see if I can get the slides to advance. There we go.
Yep.
All right, so I'm going to take a few minutes to talk about getting the most from energy models, specifically through the SETA process that Jeff framed up earlier, but a lot of this is going to apply anywhere. And I'll start with why we build models in the first place. Neil and Alexi have already touched on some of this, making sure that the modeling adds value to a project. As long as the inputs are good, there's a lot you can get out of it. And what that is can change depending on what you're looking for. As has been mentioned, in many cases, models are used for sizing systems, maybe checking code compliance, maybe hitting a LEED certification level. But with the SETA program, the last three on the list here are really answering the why question through SETA, and where I'm going to dig in a bit. The first two there, optimizing performance and comparative analysis, those are really the path to the last one, looking for those energy savings and the potential for incentives. So added to that first question, why do we build energy models? I wanted to weave in some thoughts on why the SETA program exists in the first place. With any utility energy efficiency program, they're always evolving, and more utilities and regulators are looking for untapped resources, which in a nutshell is how to drive energy efficiency and energy savings where they didn't already exist. One part of that is to expand the tent, bring in teams that might not have enrolled in the past. Maybe they're teams that don't have the resources to build full energy models, but also build the program in a way so that it's still a benefit to those high-performing teams that already participate. Thinking about it in a different way, the intent of the programs is to provide a societal benefit, and whether that's conserving resources, reducing emissions, managing available energy on the grid, decarbonization, keeping energy rates low, all that helps to shape what these programs become. And I just offer that as a bit of background as we look a bit further into the SETA process. Okay, so with the modeling, what is the depth of the models, especially through utility programs? And the answer is always, it depends. How much detail do we have right now? If we're looking for opportunities in energy savings, alternate designs, of course, as has been mentioned, we'll want to start as early as possible, often starting with those shoebox models and adding more detail in later as we move along. Those early models mean we might be starting with a lot of assumptions, but they can be informed assumptions. The goal is to model what's known, draw on experience for what's not, and get the model to a point where we can test out the variables. Maybe those variables are an alternate HVAC system, looking at different envelope measures, maybe different water heating strategies. All those can be tested out to see which options generate the most savings. And we're always looking back to that goal of optimizing overall building performance and making sure that any proposed measures are feasible, impactful, and cost-effective. So on the third and the fourth bullets, balancing effort and outcome, engaging your available time, there is a balance there. I'm sure at least a few of you on the call have built some energy models, and I'm sure you know one of the risks. You could keep fine-tuning those models pretty much forever, but the question is, where along that path does the return start to diminish? From my own experience, we've found that a comparative analysis, weighing different options, will take the model to a point where pulling those levers, maybe that HVAC system or a different glazing spec, whether that brush stroke will net enough savings to ideally outweigh the costs and get you towards your goals. So there's also an option for buildings in the SETA program that might not need a full building simulation, where in that case, we look at where some measures have predetermined, call them deemed savings values, and that can still help out a lot with decision-making and incentives. Again, we would weigh that in depending on where the project is at and what information we have. And the last point here, this is a path option that's starting to roll out as we speak, that being SETA Lite. And this is where teams that have the experience and the resources to build their own models and cover the objectives we just looked at, where those teams can take on the modeling, take on the analysis part of it, and take on the documentation to submit their own projects. Okay, so what might you expect when you enroll in SETA? For one, we'll ask a lot of questions, and it's not because we're nosy, but we do want to be a collaborative partner in exploring as many options as possible. Really anything that might be feasible and relevant to the project. So we'll look at your basis of design, any alternates, compare that back to the SETA program baseline, which I'll cover in just a few minutes. But we'll also ask about those goals that Neil was talking about earlier. Make sure that what we're doing is aligned with the needs specific to each project. Now, the general process, as Jeff covered earlier, we'll set up those 2 formal meetings, the first being to review the available information on scope and options, and the second being that interactive modeling session where we test out the design options, those alternates, and see which ones yield the best results. The modeling tools themselves can depend a bit on the scope of the project too and how much time is available, which can drive the depth to which the models are refined. But in the basic SETA program track, we handle the modeling and the paperwork, which I'm sure you can guess there is a level of documentation to get projects submitted for review, and of course, approval of incentives. So that's really a snapshot of what's happening in the design phase, and we'll talk in just a few minutes about what happens later on. And of course, there's a lot more we could dig into, but I'll try to sum all of that up by saying that the purpose of the SETA program from the eyes of the project team is, excuse me, to offer an accurate comparative analysis, again, early enough in the design to allow you to evaluate any energy efficiency options that might be on the table. Okay, so we covered the point that the model should match the team's goal, and ideally the modeling goes to the depth that's needed. As an example, the plans on the right, they imply a schematic level, but for sure they're far enough along to start a shoebox type model, meaning an early model once you know the general space and usage needs. And then with the right inputs, a model from those layouts can be incredibly valuable in looking at different options at a time when those options are still on the table. That last piece is really key, and I'll repeat that, energy efficiency options that are on the table. It does touch on one of the SETA program objectives, that being moving the needle for projects. We do have to be realistic and consider that if a project is far enough along that there aren't any options on the table, in other words, if the design is fully baked, the utilities and the Public Utilities Commission, they'd weigh that against the goals of the program, again, driving energy savings where they didn't already exist, decarbonization and so on. In the end, SETA was designed to move projects further than they might have gone otherwise, to incentivize added efficiencies, and not just to reward what would have already happened. And that balance, incentivizing or rewarding, I'm sure I could talk about that for another hour at least, but the key there is whether the program is moving the needle, and projects that still have opportunities to go further can capture some of those incentives. In a nutshell, that third point there, SETA isn't savings by design. There are some differences, but it all goes back to those goals of the program and balancing out what's being offered by how well the program can move the needle. One difference is the baseline, which for SETA, the baseline is close to Title 24, but layering in some modifications. And that's where current technologies and practices are already understood to exceed Title 24. Thinking about it in that way, that's the baseline to which projects are compared is what's considered a standard practice baseline. Now, there are a few new opportunities through SETA also, one being a higher incentive potential for projects that qualify as all electric. And that gets back to that decarbonization goal. And there's higher incentive options for projects serving disadvantaged markets. That's like low-income housing. One more is a way higher cap on incentives. And that's up to $1 million now instead of the cap being $150,000 under savings by design. So then thinking about the actual savings opportunities, what are we looking at for projects? So we can really take a look at anything under the roof and see where the potential is. Some of the areas where we're seeing increased opportunities and ones that support the goals of electrification are things like heat pump water heating, overall system switches to all electric, like with VRF systems, maybe heat recovery chillers in larger projects. But really, if something in a building uses energy or retains energy, thinking about the envelope here, we can take a look and see whether it fits into the mix. So we're talking about a lot of things that happen during the design process, but eventually the project gets built, and we'll want to take a look and see how things shaped up. Of course, recognizing that occasionally something in scope might change along the way. Yeah, that never happens, right? But just in case, after the construction wraps up, we'll review the as-builts and visit the project site to see if anything's changed with any of the planned energy efficiency measures. And with that, we'll true up the energy models and resubmit for final payment of incentives. Now, with that, there are some cases where projects might be quite atypical, or the systems are highly unique in some way. In those cases, program reviewers may ask for some data logging, and that's to ensure that the claimed savings are aligned with the actual outcome. So we'll manage, and that's something that our team will manage where it's needed. Okay, so that's pretty much it, start to finish, and a few thoughts in there about how to approach different options along the way. But as I close out this section, I just wanted to share a few thoughts. With energy modeling, Neil mentioned, is that modeling just to check a box? And we'd like to think of this as not just modeling, but really thinking about this as a larger process of consulting. Again, I'll repeat once more, weigh your options as early as possible. Again, when they're still on the table. And I did want to say that at every experience level, right? I mean, I'm sure there's a lot of folks on the call here that do their own energy modeling. Maybe there's some that don't, or hire it out, or maybe haven't done much modeling. But at every experience level, we'll try to find a way to leverage the program to help the team out, help drive some additional savings, optimize performance, whatever those goals might be. And lastly, a challenge that I just like to share anytime I have an audience is model every project. Everyone is different. The building that you build and design today might look a lot like one that you just built down the road, but some conditions might be different. And the only way to understand what's really best for each project is to model every project. So with that, I'll turn it back over to Alexi if you wanted to bring us home here.
Thanks, Rich. And actually, I think these takeaways are a really good way to start bringing us in, because I think I like the challenge you've set for folks, and appreciate the good rundown of the process. We have some time here at the end for Q&A. So Connie, do you want to explain how Q&A works, and if you've got some in already? Great.
Sure. I'd like to invite our panel to go ahead and turn on their cameras for this section 2, if you are comfortable with that today. And don't forget, we're going to send out the links to both the slides and the recording tomorrow. So if that's one of your questions, there's the answer. So if you do have any other questions, go ahead and enter them into the question pane, and we'll work our way through as we can. Hello, everybody. All right, our first question, is it possible to benefit from the technical assistance without pursuing the incentives? Potentially, project schedule could prevent certain projects from attaining incentives, but it sounds like that technical assistance is a very valuable resource.
I'll jump in on that. That is an extremely good question, and I have to admit it's not one I've heard before.
Yeah, Rich will have to do some research on that one.
Yeah. I mean, if you think about it from the perspective of the utilities and the CPUC, again, they're looking for the program to help drive savings. and we'd have to weigh whether the savings achieved through that study, I mean, ideally we'd be able to submit those as a claim for incentives, but if projects are too late, I would have to check and see if that's something we could pull through the program. But as I mentioned earlier, there are some options for projects that are maybe a little further along in the design process, you know, not yet complete, but maybe don't have the time for the full energy model. And that's kind of the deemed path to say, okay, so you've got some energy efficiency measures. Can we look at any of those to compare and possibly get some incentives without running through the full modeling process? And I realize I'm actually answering the opposite question. This is kind of looking for the incentives and the comparison without the model. But yeah, Jeff and I will dig into that and get some thoughts back to you. I appreciate the question though.
Okay. So we have another question that came in. The building energy modeling community is facing more pressure to perform predictive modeling for either meeting EUI targets or net zero performance. How does SETA modeling fit in?
So with that, I think I might have to ask for some clarification. There's two things I can think of with predictive modeling. For the most part, what we do is predictive modeling to try to understand how a building will perform based on the uses, the expected occupancy, the schedules, anything that fits into how a building is going to use energy. So in that respect, it's all predictive. There's a second part to that I do get questions about occasionally, which is using predictive weather files, meaning the climate that we see today is likely not going to be the climate that a building is going to be dealing with 10 years down the road. For the time being, most utility programs in SETA use current weather files. But there is definitely something to that in terms of trying to figure out, you know, how is something going to be different if with climate change down the road. That's something that would need to be studied outside the SETA program. So I hope one of those answers your question, but feel free to toss something else in the chat if that doesn't help.
I could weigh in real quickly that it's a challenge everyone's facing, and it's just historically a challenge with the fact that over half the assumptions we make are how humans interact inside the buildings and what they do. So there is no perfect way. CIBC has done a great job. They have a design guide called TM54, if people aren't familiar with it, just to present whisker plots on energy use intensity for different end uses to say, hey, if you leave all your lights on, it could be twice this number. And that's just, I've seen a great way to communicate risk. So how that gets done in each type of modeling you might use, it could be an actual another set of runs you do. It could also just be an educated range that the modeler puts on the chart for when you hand it over to the audience who doesn't understand the accuracy of these numbers or how they could shift. I would sort of empower people to use their best judgment to give that level of feedback. I would say there is no one answer right now in the industry. Everyone's trying to find ways to communicate this. So. And
Neil, I think you just touched on this, but does the modeling process also take into account occupant factors other than into account occupant factors such as regional or contextual aspects?
Regional. I guess I'm struggling to fully, I don't know if I fully understand the question.
So occupant, and I mean, obviously occupant, and then probably regional demands as far as, you know, the sun and.
Sure, yeah, I mean, so in the work that I'm doing, yeah, we try and use the best information we can to inform when are people going to be in the building or needing different resources. And Rich, you could step in, but I believe the SETA program also moves in that direction where, codes might use, you can only represent a building's uses in this pattern. And I believe CETA also sort of takes the approach of like, what is your best knowledge of how you use the building? Let's use that to inform things.
Yeah, absolutely. It's part of that investigation that we do at the beginning of any project, trying to understand, what are the hours of the different spaces of each project? How are those spaces being used? What are the plug loads in those spaces? Knowing that any of that can change after a building opens, but we try to make our best assessment of how those buildings are being used, using weather files that are specific to the climate that the building is in, and just making sure that any of those variables that we can nail down, that we'll bring those into the modeling tools.
And I think, given that CETA isn't exactly the same as code compliance, the idea is to get an accurate idea of what's going on in the building. So trying to get an idea of what are the schedules? When do people come in? When do they go? What turns on when and how? The key is that it's the same from baseline to proposed. So you want to get an accurate picture and the schedules stay the same. That's one.
Exactly.
Let's get that asterisk.
Yeah, thank you for that.
Okay, this question is directed at Jeff. Jeff, you said that the program is looking for buildings exceeding 30,000 square feet. Is that conditioned square feet? Also, does the program's verification process overlap with the verification part of the commissioning process?
The 30,000 square feet, it is conditioned area, correct, Rich? I gotta lean on you. I think it's.
Yeah, so again, we always have to answer with it depends, because even in conditioned spaces, there are going to be some energy uses, lighting in a unconditioned, naturally ventilated garage. So if there's enough of that that we can look at and see where the savings lie, we can certainly consider something. It's not going to be something where we would automatically kick a project out if they're at 29.9, but they have a big garage. So it's something that we're always happy to look at and chat with project teams about specific projects to see if it's something that we can bring through CETA or if there might be other paths.
And then Connie, the second part of that question, the verification, I believe it was.
Yeah, does the program's verification process overlap with the verification process part of the commissioning process?
No, our verification is separate. We're simply coming in and seeing what was in fact installed. So it does not overlap. No.
Okay, thank you. And so there is another specific question. Is there a list of programs that we cannot apply for if we pursue this one, to avoid double dipping?
Oh, good question. It might vary by utility. That's something we'll probably have to gather for you.
Okay, I can pass
it really all
along.
boils down to whether or not you're looking to achieve any incentives or rebates through something that's utility sponsored, or that's done under the CPUC. There have been some questions about outside funding sources for things like low income housing, things like that, and that's completely separate from utilities, and that is not something that would prevent you from enrolling in the CETA program. But yeah, the actual programs themselves, we might have to dig into that.
Great, thanks. And I think we might have time for one more question. This one, I think you have a little bit to expand on. How does CETA Design Assistance help to achieve the greater life cycle savings in a building?
Yeah, good question. And let me think about that for just a second. In terms of greater life cycle savings, there's a couple of ways that we can look at that. There's the annual savings that you'd see for any energy efficiency measure, and I realize that most utility energy efficiency programs have looked at say, first year energy savings to see what, how many kilowatt hours, what's the reduction in peak kW, how many therms of gas are you saving in that first year, and then calculating incentives based on that. That doesn't go away as you extend out further into the life of the project. What SETA does a little bit differently is looks at the incentives and the analysis as the life of the equipment. So instead of saying first year energy savings, we look at, well, what is the actual life expectancy, the effective useful life of the equipment, of the the windows, the mechanical systems, lighting, and we will come up with an averaged effective useful life of the project, and the incentives are actually calculated based on that. So energy efficiency measures that last longer have more potential for a higher incentive than ones that might have a much shorter lifespan. So I realize I'm not entirely answering the question by talking about that, but with any energy model, if we compare the cost to the savings to the potential incentives, we can kind of look at that full life cycle and do the math to see, does something pay back after a certain point, and where do the energy efficiencies start to achieve additional energy savings throughout the life of a project.
Excellent. Anything else that we need to add here? Anything, burning comments that need to come up before we log off today?
Just one note in terms of the bigger picture of life cycle savings. One reason that people are pursuing high performance buildings is not just reduction in cost, but also reduction in carbon. And so SETA actually does offer higher incentives for all electric buildings and incentives that ratchet up as percent savings go up. So that is one angle that where the program is pursuing, or is trying to drive people toward decisions that get us more efficient buildings and lower emissions impacts at a societal level.
All right. Well, we have
Richard, Jeff, really quick.
Sorry.
Just wanted to give you a chance for a quick closing comment.
No,
Oh,
closing
yeah,
comment.
thank you.
Sorry, again, I'll stress timing. Always, I've come up with time and time again. Get your applications in, never too early. Go ahead, Rich.
Absolutely. I can't say much more than that. I do want to say thank you all for attending, and the great questions. Those are fantastic.
Yeah.
Thank you.
Great. Well, we have a variety of new resources coming up in support of SETA, so keep your eye on your email for the release of some fact sheets and case studies. So thank you again for joining us. Thank you to our presenters today. That was a great presentation. And the survey will pop up as you log out, and make sure you are entering your AIA number there if you are seeking credits. So thanks everybody, stay safe and stay well.
Thank you.